Hey team, let's talk about insulation resistance testing. Firstly, what is it? Well, it's exactly what it says in the name. I want to test the resistance of my insulation. Now, when I first say that, that might not make much sense to you. How can the insulation have resistance? Insulation is there to ensure that two things that are separate remain separate. They're insulated from each other. So there's no circuit between. How is there resistance there? Well, look, everything has resistance. Obviously, our conductors are made of copper or aluminium, maybe gold and silver inside of our electronics. These things are really great conductors, and so if I test the resistance of those things, it's typically going to be very, very low. But everything has resistance. Given enough voltage, everything is a conductor. Lightning can strike from the clouds to the earth through the air. With a high enough voltage, we can even make the air into a conductor, even though on a typical day-to-day basis we use air as an insulator everywhere, right? Anything that I'm not touching just means that there is air insulating between me and that live thing. But as I say, even in the case of lightning, even air can be a conductor, so everything can be a conductor, even the insulation on our cables. So everything has a resistance. So what I'm doing when I do insulation resistance testing, and I'm testing the resistance of my insulation, typically on a conductor, inside a cable. It could be on an appliance, it could be on various other things. What am I looking for? Why would I do this? Well, as you can imagine, if we're looking at this cable here, I want all of these things to remain separate. The earth wire there, anything that's connected to that earth wire, if this was a TPS cable in the walls or ceiling of my house, anything that's connected to that earth wire is going to be connected back to the earth bus bar in my switchboard, which is connected to everything else that is earth, including the body of any appliance that's plugged in and the exposed metal of anything else that's bonded in the house. Usually going to be sink, your water pipes, shower trays, anything like that. And so if I got any live voltage onto this green wire here, or in fact any green wire in my house, that's going to liven every piece of metal that is connected to my earthing system. That's really bad. We also know that the black one there, the neutral, he's going to be connected to my earthing system as well. Inside my switchboard, I have a link between the earth and the neutral, which means all of the neutrals in my house, in any installation, and all of the earths are all connected together. Anything that could liven those up is a risk to myself and anybody else who's using that installation. So that means we need to ensure the integrity of the insulation between the red one, that's the hot one, live at 230 volts, and the other two. So I need to test all live conductors to earth. In this case, red to green and black to green. Black as the neutral is defined as in our standard as a live conductor. Let's have a quick look at our standard and what does it say about insulation resistance testing. I'm already at section 8, which is verification, or another word for inspection, and section 8.3 is testing. This is where we go to find any information about testing that we need to do on an installation. If I scan down there a little bit, I can see that paragraph 8.3.3 outlines the mandatory tests, and item B on that list is insulation resistance testing. So that means that whenever I install a new circuit or do any work on an existing installation, or if I build a new one of the things that I must do at the end of that is insulation resistance testing. I need to do all of those mandatory tests, but obviously insulation resistance testing is one of those mandatory tests. It says they're in accordance with clause 8.3.6. So let's go find that clause and have a look what it says. There it is right there. Insulation resistance. It talks about various things there, the reasons why we do insulation resistance testing. I'm not going to tell you that now. You can go and find this in your own book and read all about it. But one interesting thing here is it says the integrity of the insulation is stressed by applying a direct current at 500 volts. What does that mean? So if I'm doing this test, I need to have a meter that's going to put 500 volts, and it's going to put 500 volts between these conductors. What that means is if anywhere along this cable there is any connection between, let's say, the red and the green, phase and earth, any connection at all, we're going to find it. If I just use my regular multimeter and there was a really high resistance connection between the phase and the new earth, the multimeter might not find that. It's only a couple of volts. So the insulation is probably going to be good enough. But if there's a little connection between those two, and I put 500 volts on there, that 500 volts is going to find it. Okay, so we're going to use 500 volts, and we have meters that will do this. So they're just like our ohm meter, just like our multimeter. They're testing for resistance, but they're testing for resistance with 500 volts specifically for this insulation resistance tester, or rather for this insulation resistance test. That's to find any tiny leak between any of these conductors. And why would they be there? Well, I mean, if you've got a piece of cable off a roll that you'd bought from the wholesalers, there shouldn't be anything wrong with it, right? That's a fairly safe assumption, should be. But if you think about me installing all of the wiring inside a house and then coming back at the end to fit off and then do all my testing, I'm not really sure what's happened in between there, particularly if I'm putting the wiring into just the framing of the house, and then the cladding goes on the outside, the jib goes on the inside, and anything could have happened in the meantime, right? The builders or the jib stoppers could have accidentally put a nail or a screw through one of my cables. A plumber might have come along and chewed the cable because he was hungry. We don't know. We don't know what's happened. So before we turn anything on, this is one of the tests that we're going to do, insulation resistance testing, to make sure there is no connection between any of our phase and earth wires or any of our neutral and earth wires in our installation. So let's have a look at how we're going to do it. Here we have a handy dandy insulation resistance tester. Let me just fix my camera here. There we go. Flip that around so it's so you can read it. Okay, so it's much like our multimeter, and in fact you'll find that this is loaded with a couple of spare functions in it. It's got, we can see that little wavy line and then the dotted line for AC and DC, and it's got a V there, so that means it's going to test AC or DC volts. This one's handy, it doesn't need me to tell it whether it's AC or DC. It'll figure it out itself, so that's quite nice. I've also got the ohms and the buzzer symbol on there, which tells me that it's just a standard resistance tester. And then we can have it, if I touch my leads together, you can see that it's giving me a reading through the leads there. And then I've got 250, 500 and 1000 volts. So those are my insulation resistance test functions. We're going to use 500 volts because it said it in the regulations there that it must be, we must use 500 volts. That's because our typical supply is 230 volts. The peak voltage of our 230 volt supply is 325. That's the peak of our waveform. And so if we use 500 volts DC, then we know that we're testing at a voltage higher than this cable would ever be connected to. So if it's safe at 500, it should be safe on 230 volts. One thing you might be wondering, 500 volts, is that safe? Well, yes. Is it 500 volts? Yes, it is 500 volts. Is 500 volts safe for us? Not really. But this little guy here, this meter, it's just powered by batteries. It doesn't have the juice to be able to hurt me. So I can pretty safely use this. They wouldn't sell them, let's be honest. They wouldn't sell them out on the street. You wouldn't be able to go into a shop and buy one of these if they weren't safe. So that will put 500 volts on you if you touch it. If I touch the two terminals across me, it's not going at the moment. I need to push the yellow button first. But it will give me 500 volts. Is that enough to hurt me? No. When I say is it enough to hurt me, is it enough to harm me? No. Is it enough to hurt me? Yes. It will give me a fright. It will hurt, it will make my finger hurt. I'm not going to show you, not because I'm scared, but because, you know, health is safe. I'm not going to deliberately hurt myself on video. That would be stupid. Ask me one day, we're in the workshop, we'll play a little game of insulation resistance chicken. Okay, now how do we work this? I put it on 500 volts because it's 500 volts and that could hurt us. It doesn't turn on straight away. I have to push the test button for it to work. And if I push the test button and hold it down, we can see that my leads are not connected, so I should get a very high result. There is no no connection between my leads. And you can see there it says OL, which means overload, which is out of the range. So it's the most that this meter could possibly test. And so that's a good reading. Oh, you can see it's getting a little bit there. That's 2,800 mega ohms, 2,800 million ohms, which would be 2.8 billion ohms. That's a lot. Well, what does my reading need to be? Let's go back to our standard and have a look. So if we go through our paragraph on insulation resistance testing here, it should be able to tell us, right? That would make sense. This is not much value in having something like this if it doesn't tell me the answer. So I look at paragraph 8362 here, and it says results. The insulation resistance between the live and earth parts of an electrical installation or parts thereof, including consumer mains and submains, that's what we're talking about, cables and conductors, shall not be less than 1 mega ohm or 1 million ohms. There you go. So the answer is, if I'm testing a cable or a circuit inside a house, the result that I should get should be greater than 1 million ohms. Well, let's have a look. Let's test between phase and earth. Just pop those on there. Try and twist that around so I don't have to hold it while I'm testing. Now, this is only it's a pretty short cable, so we should pretty comfortably get 1 million ohms, maybe even more. And you can see that I've got my probes here connected, one to the phase, one to the earth, and I'll just push and hold the test button. Let's see what it says. Yeah, once again we're sitting at around 3,500 mega ohm, 3,000. It's bouncing around a little bit, but it's certainly high enough, right? It's in the thousands of mega ohms. I only need 1 mega ohm. So in the thousands is heaps. Well, what does it look like if it's a fail? Well, let's just pop those down there. We'll keep that on. And if I grab the other end of the cable here, if I were to connect the red and green wires here, then obviously I now have a circuit, given that my tester is connected to the green and red wires. This is just two ends of the same cable. So if I tested this now, it should be a very low reading. It's connected directly here, so I should just get the resistance of the conductors themselves. Let's have a look. Oh yes, and we can see there that says 0 mega ohm, 0.000, which is obviously very, very low. So that would be a failed reading. That is less than 1 mega ohm. Why is it failed? Well, we can see, because I have physically joined that phase and earth at the end of the cable. So you can imagine that if a clumsy builder had screwed through the cable and that screw was in between, had screwed in between my red and my green wires and it was touching both of them, this is the sort of reading that we would get. And this is exactly why we do this kind of test, because we want to prove that all of our conductors that are not supposed to be touching are in fact not touching. Because this is a mandatory test in any installation, and in fact on any appliance that we repair or test in accordance with ASNZS 3760. That means every time I do any work on an installation, or I am putting a new installation into service for the first time, I must do the insulation resistance test on everything. Every conductor and cable in that whole building has to be insulation resistance test. It's not as tricky as it sounds, because if they're all connected together, I can test them all at one time, but that's beyond the scope of what we're talking about today. I think that's it. That's how you do insulation resistance testing, team. We're going to have some practice next time we're in the workshop, no doubt. It's not as tricky as it looks, but you'll need to do it a few times before you get the hang of it. Thanks for watching.